Now think about the last thing you tried to learn. Maybe it was for work. Maybe it was a new skill. Maybe it was something you read in a book or watched in a video. Got it. Good. Now answer me this. Can you explain it to a 10-year-old?
Yeah.
Okay, let that question hang. Open your eyes. If you hesitated, if you thought, well, maybe, sort of, I think so, then here's the hard truth. You don't actually understand it, and that's okay. Because today, I'm going to teach you the exact trick Richard Feynman used to become one of the greatest minds in physics. The same trick that helped him win a Nobel Prize. The same trick that made him legendary for being able to explain the most complex concepts in ways that anyone could understand. And here's the beautiful part. You can use this trick today, right now, on anything. Hey, pause, smile, I know what you're thinking. Another learning hack, another productivity tip, another thing that sounds great but doesn't actually work. But this is different, because this isn't about tricks or shortcuts. This is about understanding how your brain actually works and then working with it, not against it. So let me tell you a story. It's 1961. Feynman is at Caltech, already a famous physicist, and a student approaches him with a question. Professor Feynman, the student says, can you explain why spin 1/2 particles obey Fermi-Dirac statistics? Now, this is a standard quantum mechanics question. Any physics professor could rattle off the answer. There's an equation, there's a derivation, there's a textbook explanation. Feynman pauses, he thinks, and then he says something unexpected. I'll prepare a freshman lecture on it. The student is confused. A freshman lecture for an advanced quantum mechanics concept. But Feynman is serious. He goes away to prepare. Slow down here. A few days later, Feynman comes back, and he says, you know what? I couldn't do it. I couldn't reduce it to freshman level, which means we don't really understand it. All right, let that land. Let me repeat that. A Nobel Prize winning physicist, one of the smartest humans who ever lived, just admitted that he didn't really understand something. Not because he couldn't do the math, not because he didn't know the equations, but because he couldn't explain it simply. And in that moment, Feynman articulated something profound. If you can't explain something simply, you don't understand it. This became his standard, his test, his trick, and it changed everything. A walk across stage. Let me ask you something. How do most people learn? They read something, they highlight it. Maybe they take notes. They tell themselves, okay, I've got it. And then they move on. Or maybe they're more diligent. They read it twice. They make flashcards. They review the material. They memorize key points. And you know what? They still don't understand it. Because here's what nobody tells you: reading is not learning. Memorizing is not understanding. Let me prove it to you. Point to audience eye. How many of you have read a book, gotten to the end and thought, that was great? And then a week later, someone asked you what it was about and you can barely remember. Pause for recognition. Yeah, all of us? Or how many of you have sat through a presentation, nodded along, understood everything in the moment, and then walked out completely unable to explain what you just learned? More recognition. This is the illusion of knowledge. And it's everywhere. Your brain is a lying liar that lies to you. It tells you that you understand things when you don't. It confuses familiarity with comprehension. It mistakes recognition for knowledge. Feynman understood this. He understood that most of what we think we know, we don't actually know. We just know the words. We know the surface. We know enough to fool ourselves, get intense. And this is why people stay stuck. They read all the books. They take all the courses. They consume all the content. And they never actually learn anything, because they never test their understanding. They never expose the gaps. They never do the hard work of actually thinking. But Feynman had a solution. All right, let me break this down for you. The Feynman technique. 4 simple steps that will revolutionize the way you learn. Start count on fingers. Step 1 is choose a concept you want to learn. Anything, literally anything. Quantum physics, marketing, cooking, relationships. Doesn't matter. Pick something you want to understand. Step 2, teach it to a child. Not actually to a child, though you could, but pretend you're teaching it to a 12-year-old, or your grandmother, or someone who knows absolutely nothing about the topic. And here's the key: use simple language, no jargon, no technical terms, no shortcuts. If you want to explain how an engine works, you can't just say combustion chamber and move on. You have to explain what combustion is, what a chamber is, why it matters, Step 3, identify gaps and go back to the source material. This is where it gets interesting, because when you try to explain something simply, you will get stuck, guaranteed. You'll hit a point where you realize, wait, I don't actually understand this part. Akaspausa, that moment, that's gold. That's where learning happens. Because now you know exactly what you don't understand. You're not fooling yourself anymore. You've exposed the gap. So you go back. You study that specific part. You break it down. You figure it out. Step 4, simplify and use analogies. Once you understand it, make it even simpler. Use analogies. Use metaphors. Use stories. Because if you can connect new information to something people already understand, they'll get it instantly. Thar snap fingers said like that. Now, you might be thinking, okay, that sounds nice, but why does this actually work? A fair question. Let me tell you what's happening in your brain. Or get excited about this. When you read something, your brain creates a very shallow neural pathway. It's like walking through tall grass once, you barely make a trail. But when you try to explain it, when you struggle to find the words, when you reorganize the information in your own way, your brain has to work. It has to fire multiple neural pathways. It has to connect different areas. It's like walking through that grass 50 times. You create a highway. This is called elaborative rehearsal in neuroscience. And it's the most effective way to create long-term memories and deep understanding. But there's more. When you identify gaps, when you get stuck trying to explain something, your brain enters a state of productive confusion. And research shows this is actually optimal for learning. Because your brain is like, oh crap, I thought I knew this, but I don't. I need to pay attention now. Lean and Feynman. And here's the really cool part. When you finally figure it out, when you fill that gap and suddenly understand, your brain releases dopamine. You get a hit of pleasure, a reward. Your brain literally rewards you for learning. And what do we do when we get rewarded? We want to do it again. This is why Feynman loved learning. It wasn't just intellectual curiosity, it felt good. Let me tell you how Feynman actually used this in his life. Far share this story with energy. There's this famous story about Feynman at Los Alamos during World War II. They're building the atomic bomb. The stakes couldn't be higher. And there are all these young scientists, brilliant people, working on incredibly complex problems. But they're stuck. They're making mistakes. They're confused. So Feynman starts teaching them. Not lecturing, teaching. He breaks everything down to first principles. He uses simple language. He draws pictures. He makes analogies. And suddenly people start understanding. Not just memorizing formulas, but actually understanding what they're doing and why. One of his colleagues later said, Feynman didn't just know physics. He understood it so deeply that he could make anyone else understand it too. That's the power of this technique. Another example. After Feynman won the Nobel Prize, he got depressed. Yeah, seriously, because physics wasn't fun anymore. It had become work. It had become about reputation and publishing and being serious. So you know what he did? He started playing again. He'd watch a plate wobble in the cafeteria and think, I wonder why it wobbles that way. And then he'd work out the equations. Not because he had to, not because someone asked him to, but because he was curious. And he'd explain it to himself as if he were teaching it to a child. Okay, so when the plate spins, the centrifugal force does this, which causes this wobble, which creates this pattern. From that play, from that childlike curiosity and simple explanation, came some of his most important work on quantum electrodynamics. The work that won him the Nobel Prize started as play, and it started with simple explanations. As I get into teaching mode. Okay, enough theory. Let's get practical. How do you actually do this? Let's say you want to learn about compound interest. Basic financial concept, right? Everyone says compound interest is important. You've heard it a million times. But do you actually understand it? Let's test it using the Feynman technique. Step 1, you pick your concept. Compound interest. Step 2, you explain it to a child. Okay, so imagine you have $100, and you put it in a special piggy bank that gives you $10 extra every year. Cool, right? So after 1 year, you have $110. But here's where it gets interesting. In year 2, you don't just get $10 again. You get $10 on your original $100, plus you get $1 extra on the $10 you earned last year. So now you have $121. And every year, You earn money not just on what you started with, but on all the money you've earned along the way. So your money grows faster and faster. But see what I just did? I didn't use the word principal. I didn't use the word interest rate. I didn't use a formula. I used a piggy bank and simple numbers. Step 3. Identify gaps. Maybe you realize, wait, what if the interest rate changes? What if you take money out? What if you add money in? Great. Now you know exactly what you don't understand. Go research those specific questions. Step 4 is simplify further. Compound interest is like a snowball rolling down a hill. It starts small, but as it rolls, it picks up more snow. And the bigger it gets, the more snow it picks up each time around. Eventually, you have a massive snowball. Now anyone gets it. But here's where people screw this up. Let me tell you the 3 biggest mistakes. I count them out key. Mistake number 1, using jargon as a crutch. People try to explain something, but they can't resist using technical terms. Well, it's basically a paradigm shift in the operational framework. Stop. If you're using big words, you're hiding. Feynman was famous for this. He'd stop people mid-sentence and say, "Pretend I'm your grandmother. Explain it again." And suddenly, they'd realize they didn't actually understand what they were talking about. Mistake number 2, not actually writing it down or saying it out loud. People think they can do this in their head. They can't. When you force yourself to write or speak, you expose the gaps. You can't fake it. Your brain can't skip over the hard parts. Point ahead so your brain will lie to you. Yeah, I understand that part. Let's move on. But when you have to write it down or say it out loud, suddenly you're like, wait, I don't actually know what happens next. Mistake number 3, giving up too soon. This technique is uncomfortable. It's supposed to be. Because you're going to realize how much you don't understand. Most people hit that discomfort and quit. They think, this is too hard. I'm not smart enough. Wrong. You're just finally seeing the truth. And that's where the real learning begins. Get encouraging. Push through. Embrace the confusion. That's your brain building new pathways. Now let me tell you one of Feynman's secrets within the secret. Analogies. This is what separated Feynman from other physicists. He was a master of analogies. I share examples. Someone asks him to explain quantum electrodynamics. Impossible to explain, right? It's one of the most complex theories in physics. Feynman explains it like this. Imagine you're playing catch in the dark. You can't see the ball, but you know someone threw it because you caught it. That's kind of like how particles interact. We can't see the interaction itself, but we see the results. Is that technically perfect? No, but does it give you a foothold to start understanding? Absolutely. Or take his famous explanation of why ice is slippery. Most scientists would talk about pressure, induced phase transitions, and reduced friction coefficients. Feynman said, imagine you're walking on ball bearings. That's basically what's happening. There's a thin layer of liquid water acting like tiny rolling balls under your feet. Gesture. Instant understanding. Here's why analogies work so well. Your brain learns by connecting new information to things it already knows. If you give your brain a bridge, it's like this thing I already understand. It crosses that bridge instantly. Without analogies, you're asking your brain to build understanding from scratch. With analogies, you're giving it a shortcut to comprehension. And this is key for the Feynman technique. When you're explaining something, always ask yourself, what is this like? What does this remind me of? Here's something wild that Feynman discovered. The best way to learn something is to teach it. Sounds backwards, right? How can you teach something you don't know? But that's exactly the point. Get philosophical. When you position yourself as a teacher, even if you're just teaching yourself or an imaginary child, something shifts in your brain. You become responsible for the information. You can't just passively absorb it. You have to actively organize it, structure it, translate it. There's this concept in psychology called the protégé effect. Studies show that students who prepare to teach material to others learn it more thoroughly than students who just study it for themselves. Why? Because when you're going to teach something, you think differently. You ask, what's the core idea here? What are the most important parts? What would confuse people? How do I make this clear? Point out P. Those are the questions that lead to deep understanding. Feynman knew this intuitively. That's why he loved teaching. Not because he wanted to show off how smart he was, though he could be a bit of a showman, but because teaching forced him to understand things at a deeper level. He once said, "I couldn't do it. I couldn't reduce it to the freshman level." That means we really don't understand it. We don't understand it because we can't teach it. That's the standard. That's the bar. All right, let me give you the formula, the exact process you can use right now to learn anything. Present this as a clear system. First, consume the material. Read it, watch it, listen to it. Second, close the book or video. No peeking. Third, get a blank sheet of paper. Fourth, write at the top how I would explain this topic to a 12-year-old. Fifth, write or speak your explanation. No jargon. Simple words only. Sixth, circle every point where you got stuck. Seventh, go back to the source and study only those parts. Eighth, repeat steps 3 through 7 until you can explain it without getting stuck. Ninth, add analogies to make it even clearer. 10th, test yourself by explaining it to someone else or by recording yourself. Emphasize this as, that's it. 10 steps? You can do this in 20 minutes for a simple concept, an hour for something complex, a few sessions for something really difficult. But here's the magic. After you do this, you'll understand that concept better than 99% of people who studied it, because most people never expose their gaps. They never test their understanding. They convince themselves they know something when they don't. You'll actually know it. Let me show you how this works in different areas of life. Go through examples for students. Stop highlighting textbooks. Stop making flashcards that just have definitions. Instead, after each chapter, close the book. Write how I would explain this chapter to my younger sibling. When you get stuck, that's what you need to study. I promise you, 1 hour of Feynman technique study beats 10 hours of passive reading. For professionals, after meetings, after reading reports, after training sessions, take 5 minutes. Explain to yourself what you just learned as if you're explaining it to someone outside your industry. This does 2 things. First, you actually retain the information. Second, you'll be able to explain your work to anyone, which makes you incredibly valuable. For creatives, want to understand why certain stories work, why certain designs are effective, why certain music moves people. Use the Feynman technique. Break it down. Explain it simply. Find the principles underneath the surface. For parents, your kids ask you why the sky is blue. Instead of giving them a complicated answer or brushing them off, use this as a learning opportunity for yourself. Try to explain it simply. If you can't, look it up, learn it, then explain it to them. You'll both learn, and you'll teach them that it's okay not to know something. What matters is the curiosity to find out. Here's where this technique becomes truly powerful. It doesn't just help you learn specific things. It teaches you how to think. Get excited. This is what Feynman really understood. The technique isn't just about memorizing information. It's about developing metacognition, thinking about thinking. Every time you use this technique, you're practicing self-awareness, recognizing what you don't know. You're practicing critical thinking, analyzing and breaking down concepts. You're practicing communication, translating complex ideas. You're practicing pattern recognition, finding analogies and connections. And you're practicing intellectual honesty, admitting gaps in understanding, all pausing. These are the skills that make you genuinely smart. Not knowing a lot of facts, anyone can Google facts. But being able to think clearly, learn quickly, and understand deeply, that's real intelligence. And here's the beautiful part. The more you use this technique, the better you get at it, the faster you identify gaps, the more easily you create analogies, the more naturally you think in first principles. Feynman used this technique for decades, and it became second nature to him. He couldn't help but break things down simply. He couldn't help but question until he understood. It became who he was, and it can become who you are too. So here's what I want you to do right now. Today, direct challenge. Pick one thing. Just one. Something you think you understand but you've never really tested. Maybe it's something from your job. Maybe it's a concept you learned in school. Maybe it's something you read in a book recently. Got it. Now, here's your challenge. Explain it to someone who knows nothing about it. Actually do it. Don't just think about doing it. Find someone, a friend, a family member, a colleague, and explain it to them. Or if you can't do that, write it out. Record yourself. But actually externalize your understanding. Hey, lean in, and here's what's going to happen. You're going to get stuck. you're going to realize you don't understand it as well as you thought. And that moment, that uncomfortable, slightly embarrassing moment, that's when the magic starts. Because now you know exactly what you need to learn. Now you can stop wasting time on things you already understand and focus on the gaps. This is efficient learning. This is smart learning. And this is how Feynman learned, and it's how you can learn too. But let me tell you something deeper, something Feynman understood that goes beyond just learning facts. Get philosophical and slow down, P. This technique isn't just about learning. It's about humility. Every time you use the Feynman technique, you're forced to confront your own ignorance. You're forced to admit what you don't know. And in a world where everyone is pretending to be an expert, where everyone is projecting confidence, even when they're confused, that's radical. Feynman once said, "The first principle is that you must not fool yourself, and you are the easiest person to fool." At pause, we are all fooling ourselves about something. We all have areas where we think we understand, but we don't. We all have beliefs we've never examined. We all have knowledge that's actually just memorized words without understanding. This technique is a tool for intellectual honesty, for seeing yourself clearly, for having the courage to say, "I don't actually understand this." And that courage, that's what separates average minds from great minds. Average minds protect their ego. They pretend to understand. They hide behind jargon and confidence. Great minds protect their understanding. They admit confusion. They expose gaps. They learn. A direct statement, which one do you want to be? Let me leave you with one final story about Feynman. Wire tell this with emotion late in his life. Feynman was battling cancer. He was dying, and he knew it. And someone asked him what he was most proud of in his career. You'd think he'd say the Nobel Prize, or his work on the atomic bomb, or his contributions to quantum physics that changed our understanding of the universe. But you know what he said. He said he was most proud of the Feynman lectures on physics, a series of undergraduate lectures he gave at Caltech, lectures where he took the most complex topics in physics and explained them so clearly, so simply that anyone could understand.
Positive.
Why? Because those lectures represented what he believed was most important, not just understanding, but sharing that understanding, making knowledge accessible, breaking down barriers between experts and everyone else. He spent years developing those lectures, refining them, simplifying them, making them better, because he believed that if you truly understand something, you can explain it to anyone. And if you can explain it to anyone, you can change the world. ARB, look directly at audience X. That's what this technique is really about. It's not just about making you smarter. It's about making knowledge accessible. It's about breaking down the barriers between experts and normal people. It's about democratizing understanding. There's another layer to this that I need to share with you. Because when you start using this technique regularly, something interesting happens. You start to see the world differently. Walk to the other side of the stage. You stop accepting things at face value. You start questioning more. Not in an annoying, contrarian way, but in a genuine, curious way. Feynman had this quality he couldn't help but ask why. About everything. Why does water swirl down the drain in that direction? Why do mirrors reverse left and right but not up and down? Why do we shake hands as a greeting? Some people thought it was exhausting. His friends would sometimes groan when he started asking questions at dinner parties. But that curiosity, that relentless need to understand, that's what made him brilliant. And here's the thing, you can develop that same quality. The Feynman technique trains you to be curious. Because every time you try to explain something and get stuck, you're training your brain to notice gaps, to ask questions, to dig deeper. Get passionate. This changes everything. It changes how you read. It changes how you listen. It changes how you think. You stop being a passive consumer of information and become an active learner. You stop memorizing and start understanding. You stop fooling yourself and start knowing yourself. Let me give you a real example from my own life. I thought I understood how democracy worked. I voted, I read the news, I had opinions about politics. I could talk about checks and balances and separation of powers. But then I tried to explain it using the Feynman technique. I sat down and wrote how I would explain democracy to a 12-year-old, and I got stuck immediately. Why do we have an electoral college? I couldn't explain it without using circular logic. Why is the Senate structured the way it is? I realized I'd never actually thought about it. What's the actual difference between federal and state power? I knew there was a difference, but I couldn't articulate it clearly. It was humbling. Here I was a grown adult with political opinions, and I couldn't explain the basics of my own government system. So I went back. I studied. Not everything, just the specific parts where I got stuck. And then I tried again. And you know what? Now I actually understand democracy. Not perfectly, but genuinely. I can explain it to anyone. And more importantly, my political opinions are now based on actual understanding, not just inherited beliefs or media talking points. That's the power of this technique. It forces you to be honest about what you know versus what you think you know. Now. I want to address something that might be bothering some of you. You might be thinking, this sounds great, but I don't have time. I'm busy. I've got work, family responsibilities. I get it, we're all busy. But here's the thing, this technique doesn't take more time. It takes less time. Think about it. How much time do you waste right now reading things you forget? Sitting in meetings you don't understand? Taking courses that don't stick? Watching videos that don't teach you anything? What if instead of consuming 10 hours of content and retaining 10%, you spent 3 hours using the Feynman technique and retained 90%? Do the math gesture. That's more effective learning in less time. Feynman wasn't successful because he spent more hours studying than everyone else. He was successful because he studied more effectively. He didn't waste time fooling himself. He didn't waste time on shallow learning. He went deep, he went fast, and he moved on. And here's another secret. Once you get good at this technique, it becomes fast, really fast. When Feynman encountered a new concept, he could break it down in his head almost instantly. He'd automatically ask, how would I explain this to a kid? And if he couldn't, he'd know exactly what he needed to learn. That skill, the ability to quickly identify what you don't understand, that's a superpower. It means you never waste time studying things you already know. You never fool yourself into thinking you understand when you don't. You go straight to the gaps and fill them. I fair point to audience, imagine having that ability. Imagine being able to look at any topic and immediately know, I understand these 3 parts, but I don't understand these 2 parts. Let me focus on those. That's efficient learning. That's what this technique gives you. Let me tell you about another time Feynman used this approach, and it's one of my favorite stories. I share this story with energy. Sir Feynman was once asked to serve on a committee evaluating science textbooks for California schools. He agreed, thinking it would be straightforward. Look at the books, see if they're accurate, give feedback. But when he started reading the books, he was horrified. The books were full of words, big words, scientific-sounding words. But when he tried to understand what they were actually teaching, he realized they weren't teaching anything. There was one book that had a whole chapter about energy. It defined energy. It categorized different types of energy. It used the word energy on every page. But it never explained what energy actually is. It never gave students a way to understand it, to visualize it, to connect it to their experience. Feynman tried to explain energy the way the textbook did. He couldn't. It was just circular definitions and empty terminology. So he tried explaining it his way. Energy is like money. You can't see money directly. You see dollars, coins, checks, bank accounts. Energy is the same. You can't see energy directly. You see motion, heat, light, sound. But just like you can convert dollars to coins to checks, you can convert motion to heat to light. It's all the same thing in different forms. Boom. Now a kid understands energy, but the textbook couldn't do that because whoever wrote it didn't actually understand energy deeply enough to explain it simply. And this, Feynman realized, was everywhere, in schools, in businesses, in government, people using complex language to hide simple ideas. Or worse, using complex language to hide the fact that they have no ideas at all. Get serious, this is why the Feynman technique matters. Not just for you, but for society. Because we live in a world where complexity is mistaken for intelligence, where jargon is mistaken for expertise, where confidence is mistaken for competence. And that's dangerous. When politicians use complex language to avoid explaining their policies, that's dangerous. When companies use buzzwords to avoid explaining their products, that's dangerous. When experts use jargon to avoid admitting they don't know something, that's dangerous. The Feynman technique is a weapon against that. It's a tool for cutting through bullshit. It's a standard for honesty. If someone can't explain their idea simply, they don't understand it. Period. Point directly at audience, and you have the power to hold people to that standard. When someone gives you a complicated explanation, you can say, "Can you explain that more simply?" When someone uses jargon, you can say, "Pretend I'm 12. What does that mean?" You'll be amazed how often people can't do it. And you'll be amazed how clarifying it is when they can. Now, I want to talk about something Feynman discovered that goes even deeper. He realized that understanding isn't just about breaking things down. It's also about building them up. Shift to a more thoughtful tone. See, there are two ways to learn something. You can take something complex and break it into simple parts. That's analysis. That's what we've been talking about. But you can also take simple parts and build them into something complex. That's synthesis. And that's where creativity lives. Feynman was brilliant at both. He could take quantum mechanics and break it down into simple ideas anyone could understand. But he could also take simple ideas and combine them in new ways to create breakthroughs nobody had thought of before. And the Feynman technique trains both skills. When you're trying to explain something simply, you're doing analysis. You're breaking it down, finding the core components, understanding the relationships. But when you're creating analogies, when you're connecting new information to things you already know, when you're reorganizing ideas in your own way, that's synthesis. That's creativity. Get excited. This is why people who master this technique don't just become better learners, they become better thinkers, better problem solvers, better creators. Because they can move fluidly between breaking things down and building things up. Between understanding and innovation, Feynman did this constantly. He'd learn about biology by breaking it down to first principles, and then he'd see connections to physics that biologists had missed. He'd learn about computing and see possibilities that computer scientists hadn't considered. He'd learn about art and find insights that applied to science. That's the ultimate goal here. Not just to understand individual topics, but to see connections between topics. To build a web of understanding that lets you think across disciplines, combine ideas in novel ways, solve problems nobody else can solve. And it all starts with being able to explain things simply. Let me give you one more practical example before we wrap up. And this one is personal. Get vulnerable. I used to think I was pretty good at communication. I could write, I could speak, I could present. People would tell me I explained things well. But then I started really using the Feynman technique, not just occasionally, but systematically, on everything. And I realized I wasn't as good as I thought. I was good at sounding smart. I was good at using the right words. I was good at performing knowledge. But when I tried to explain complex topics to actual 12-year-olds, I struggled. When I tried to explain my work to my family, they didn't get it. When I tried to teach something without using any technical terms, it was hard. I had been fooling myself. So I practiced. I used the technique over and over, on my work, on things I read, on ideas I had, everything. And slowly, I got better, not just at explaining things, but at understanding them. My thinking became clearer, my work became better, my conversations became deeper. Look at audience ease. And here's what I want you to understand. If you're not regularly testing your understanding by trying to explain things simply, you're probably fooling yourself too. We all are. It's human nature. But you can change that today, right now. All you have to do is commit to using this technique. Not once, not occasionally, but as a regular practice. Every time you learn something new, explain it simply. Every time you think you understand something, test that understanding by teaching it. Every time you hear complex language, challenge it by asking for simple explanation. Make it a habit. Make it a standard. Make it who you are. So here's what I want you to remember. Or slow down. Make this powerful. You are capable of understanding anything, literally anything. If you're willing to do the work, if you're willing to break it down, if you're willing to expose your gaps and fill them. The Feynman technique isn't magic. It's just a systematic way of doing what great learners have always done. Question, simplify, and test understanding. But it works. God, does it work? I've seen it transform students who were failing into students who excel. I've seen it help professionals master new skills in a fraction of the usual time. I've seen it give people confidence they never had before, because they genuinely understand things now instead of just memorizing them. And I know it can work for you too. I found a final challenge. So here's my challenge to you. One more time, use this technique once. Just once. On one topic. See what happens. Pick something you think you understand. It doesn't have to be complex. It doesn't have to be important. Just something. And then sit down with a blank piece of paper. Write at the top how I would explain this to a 12-year-old and write or speak or record yourself. Whatever works for you. And when you get stuck, and you will get stuck, don't give up. That's where the learning is. Go back to the source. Figure out that specific part and try again. Do this for 20 minutes. That's all. 20 minutes. I promise you, those 20 minutes will teach you more about learning than a semester of traditional study. And maybe, just maybe, it will change the way you approach learning forever. Of our smile, because that's what happened to Feynman. He discovered this approach early in his life, and it became his superpower. It's why he could master any topic he set his mind to. It's why he could explain the most complex concepts to anyone. It's why he won a Nobel Prize. Not because he was born smarter than everyone else, but because he learned how to learn. And now you know his secret. I walk to center stage a thank you. and hey, if this resonated with you, if you're excited to start learning like Feynman learned, do me a favor, like this video and subscribe to the Mind of Richard Feynman channel. Because we're just getting started. There's so much more to explore about how Feynman thought, how he learned, how he approached problems that everyone else thought were impossible. We're going to dive into his other techniques, his approach to problem solving, his strategies for staying curious, his methods for thinking clearly. Join us. Let's learn together. Let's think together. Let's become the kind of people who don't just consume information, but truly understand it. What if the greatest obstacle to mastering anything isn't lack of talent, time, or resources? What if it's something far more subtle, a trap built into the very way most people think about learning itself? A peculiar phenomenon that happens when someone believes they understand something. The mind relaxes. It stops questioning. It moves on. And yet, if you were to ask that person to explain what they just learned in their own words, without relying on the exact phrases from the textbook, something remarkable happens. The supposed understanding crumbles. The words are there, but the meaning isn't. This isn't a flaw in intelligence, it's a flaw in method. And it's everywhere. Walk into any classroom, anywhere people are trying to learn difficult material, and you'll see the same pattern repeating endlessly. Someone reads a chapter. They nod along, make sense as they flow past. They might even highlight the important parts, underline key phrases, perhaps write notes in the margins. They close the book feeling satisfied. They've put in the time. But something crucial hasn't happened. The information has entered through the eyes, but it hasn't transformed into understanding. The difference between these two states, having information versus having understanding, is everything. One is fragile, temporary, easily forgotten. The other is robust, permanent, full. One makes you dependent on references and memory. The other makes you unstoppable. Here's what usually happens. People treat their minds like filing cabinets. They take information and try to store it away neatly, labeled and organized. This seems logical. After all, that's what we're told to do. Read carefully. Pay attention. The important points. But the mind doesn't work like a filing cabinet. It works like a network, a vast web of connections where ideas link to other ideas. Understanding one thing depends on understanding its relationship to everything else. When someone reads a physics textbook and memorizes that force equals mass times acceleration, they have information. When they can look at a child pushing a toy car across a floor and see that equation in action, when they can predict what happens when the child pushes harder, or when they switch to a heavier car, they can explain why a baseball requires more force to throw than a ping-pong ball at the same speed. That's understanding. Between these two states is where most learning fails, and there's a mental trick, a way of thinking, that bridges that gap completely. The trick isn't complicated, it requires something most people actively avoid. difficulty. Not the fake difficulty of reading the same page 20 times until the words blur together. Comfortable difficulty of writing out notes in increasingly neat handwriting. Real difficulty, the difficulty of confrontation with your own confusion. Here's how it works. Take whatever you're trying to learn and pretend you need to teach it to someone who knows nothing about the subject. Not just review it for them. Actually teach it. Explain it from the ground up. Use simple words. Draw pictures if you need to. And here's the crucial part. Do this without looking at your books or notes. What happens next is revelation. Within seconds, you'll hit a wall. Something you thought you understood will suddenly seem fuzzy. A concept that seemed clear when you read it will resist explanation. You'll reach for technical terms because you can't explain the actual mechanism. You'll realize that you know what something is called, but not what it actually is. This moment, this uncomfortable moment of discovering what you don't know, is the most valuable moment in learning. Most people run from it. They quickly flip back to their textbook to find the right words, the correct phrasing, anything to smooth over the rough patch. But that's exactly backwards. Patch is a signpost pointing directly at what you need to work on. The mind has a fascinating property. It can hold information in two completely different ways. There's the surface layer, fragile, word-dependent, context-bound. This is where most information lives after a typical study session. It's enough to recognize the right answer on a test, especially if the test uses similar wording to the textbook. But it vanishes quickly and provides no real power. There's the deep layer, robust, flexible, context-independent. Information stored here doesn't just sit passively. It actively connects to everything else. It can be accessed from multiple angles. It can be applied to new situations. It survives years of non-use. This is the kind of knowledge that makes someone truly capable. The mental trick that makes you unstoppable is simply this: force everything into that deep layer. Never settle for the surface. And the forcing mechanism is explanation. When you try to explain something in simple terms, you're not just reviewing it, you're testing it. Place where your explanation stumbles is a place where your understanding is shallow. Every concept you can't explain without using jargon is a concept you don't truly grasp. The mind can fake understanding when it's just reading. It cannot fake understanding when it's forced to construct an explanation from scratch. What happens in the brain when you read versus when you explain? Reading is passive. The author has done the work of organizing ideas, choosing words, constructing sentences. Follows along, and if the writing is clear enough, following along feels like understanding. But it's borrowed understanding. You're riding in someone else's vehicle. Explaining is active. You must build the structure yourself. You must decide what comes first, what depends on what, which details matter, and which are distractions. You must find your own words, your own examples, and most importantly, confront every gap in your knowledge head on, because there's nowhere to hide when you're the one doing the explaining. Here's the deeper principle at work. Standing isn't a thing you have. It's a thing you do. It's an active process of connecting new information to existing knowledge, of seeing patterns, recognizing the same principle operating in different contexts. You can't do this passively. The connections don't form themselves. They require effort, struggle, mental work. Someone truly understands something, they can explain it multiple ways. They can start from different points. They can use different analogies. They can adjust their explanation based on what the listener already knows. This flexibility is the signature of deep understanding. It means the knowledge isn't trapped in a single form, as a string of words. It's been decomposed into its fundamental components and can be reassembled in whatever form the situation requires. Consider how this works with something as basic as why the sky is blue. Most people who've heard the explanation can tell you it has something to do with light scattering, surface knowledge, but ask them to explain it without using the word scattering, and many would struggle. Ask them why it isn't violet, since violet has even shorter wavelengths. Most would have no answer. Ask them to draw a diagram showing what's actually happening to the light, and you'd see the understanding fall apart. Imagine someone who's forced themselves to truly understand this. They could explain it using analogies, maybe comparing it to how small obstacles affect waves in water differently than large ones. They could explain why sunsets are red using the same principle. They could predict what the sky would look like on a planet with a different atmosphere. Answer unexpected questions because they understand the mechanism, not just the label. This is what the mental trick produces. Not memorized answers, actual comprehension that can adapt to any question. The method extends beyond individual concepts. It works for entire subjects, complex systems, interconnected ideas. Take any field you want to master: mathematics, physics, biology, engineering, philosophy, whatever calls to you. The traditional approach is to move through it chapter by chapter, topic by topic, feeling satisfied when each section makes sense as you read it. But satisfaction in the moment of reading is not the same as understanding. Instead, after studying any material, close the books. Take a blank sheet of paper. Start explaining the material from scratch as if teaching someone. Don't write out memorized definitions, the concepts in your own words. Draw your own diagrams. Create your own examples. When you hit something you can't explain, mark it. Don't immediately look it up while you're stuck. What exactly don't you understand? What would you need to know to continue? Then, and only then, go back to the material. Don't just reread the section you were stuck on. This time, you know exactly what confused you. You have a specific question. The learning becomes targeted, efficient, passively absorbing information. You're actively hunting for specific understanding to fill specific gaps. This process is uncomfortable. That's how you know it's working. Comfort in learning usually means you're not learning much at all. You're reviewing, rehearsing, reinforcing what you already know. Real learning happens at the edge of your understanding, in that uncomfortable space where things aren't quite clear yet. There's something else happening here too, something subtle but profound. When you force yourself to explain things in simple terms, you're doing exactly what the greatest teachers do. You're stripping away unnecessary complexity. You're finding the essential truth underneath the technical language. Often, the technical language is needed for precision, but if you can't first explain the idea simply, the technical precision is meaningless. The brain naturally seeks patterns and connections. But it needs help. It needs to be forced to make those connections explicit. When you read that energy is conserved, that's a fact. When you explain why a pendulum swings back and forth, connecting the conversion between potential and kinetic energy, showing how this same principle explains why a roller coaster works, objects drop from the same height hit the ground at the same time regardless of their mass. Now you're building a web of understanding. The concept stops being an isolated fact and becomes a tool for understanding the world. This is why some people seem to learn so much faster than others. It's not that they're smarter. It's that they're learning differently. They're not collecting facts. They're building structures of understanding. Each new piece of knowledge connects to the structure, strengthening it, making it more useful. Someone who's just memorizing facts has to remember each piece individually. Someone who's built a structure only needs to understand the connections, and everything else follows logically. Let's make this concrete. Imagine two students studying thermodynamics. Both spend the same amount of time with the textbook. Both can pass the same test at the end of the week. The first student has memorized the laws of thermodynamics. They can state them. They can recognize them in problems. They can plug numbers into equations. 6 months later, they've forgotten most of it. The equations are gone. The specific problems they practiced are gone. If you ask them to explain why an ice cube melts in a warm drink, they might remember it's related to entropy. The connection would be vague. The second student did something different. After reading about thermodynamics, they spent time explaining it without the book. They started with simple questions: what is energy really? Why can't it be created or destroyed? What does that actually mean? They drew diagrams showing energy flowing from hot to cold. They explained why perpetual motion machines can't work. They connected it to everyday experiences. Why a hot cup of coffee cools down. Why a refrigerator needs power. Mixing hot and cold water always gives you lukewarm water. Never one drop of boiling and one drop of frozen. 6 months later, this second student still understands thermodynamics. Because they have better memory, but because they built understanding instead of memorizing facts. The structure is still there. The connections are still there. They can reconstruct the specific equations if needed because they understand what the equations mean. This is the power of the method. It's not a shortcut. It takes time, requires real mental effort, but it produces something completely different than traditional studying. It produces understanding that lasts, that applies, stronger over time instead of fading. Think about any skill you've truly mastered. Not something you've memorized, but something you can actually do. It's riding a bicycle, playing an instrument, speaking a language, working with your hands. Notice how your understanding of that skill isn't a list of facts. It's something deeper, something you can't fully put into words, but that you can demonstrate and apply in countless ways. That's what real understanding feels like in any domain. The mental trick that makes you unstoppable is bringing that same quality of understanding to everything you learn. Most people think that kind of deep understanding only comes with years of practice. But it doesn't. It comes with the right kind of practice. Kind of practice is forcing yourself to explain, to teach, to reconstruct understanding from first principles. Here's what this looks like in practice. Start with whatever you're learning right now. It doesn't matter if it's calculus or carpentry, history or chemistry. After your next study session, close everything, a blank piece of paper, or find a friend who doesn't know the subject. Explain what you just learned as if you're teaching a bright student who's never encountered this material before. Pay attention to where you struggle. Those struggles are information. They're showing you exactly where your understanding is weak. Don't judge yourself for the struggles. Be grateful for them. They're making the invisible visible. Without this process, you'd think you understood everything perfectly, right up until you needed to actually use the knowledge and found it wasn't there. When you find gaps, resist the urge to immediately look up the answer. Sit with the confusion for a moment. Think about what specifically is unclear. Is it a concept you don't understand, a connection you can't see, a step in the logic you can't follow? Identifying exactly what you don't understand is itself a profound form of understanding. Go back to your materials with a mission. You're not rereading everything. You're hunting for specific answers to specific questions. This makes the second pass through material incredibly efficient. You know what you're looking for. Your mind is primed to grasp it. Then explain it again. The second time through will be better, smoother, more connected. But you'll probably still find weak spots. That's fine. That's the process. Each cycle of explaining, finding gaps, filling them, and explaining again takes you deeper into genuine understanding. The beauty of this method is that it scales. You can use it for learning a single concept in 20 minutes or mastering an entire field over years. The principle is the same. Never settle for feeling like you understand. Prove to yourself that you understand by constructing explanations from scratch. There's one more aspect worth noting. You develop this habit, this refusal to accept surface understanding. Something interesting happens. You start seeing through complexity everywhere. You start recognizing when others don't really understand what they're talking about, even if they use impressive terminology. You develop a kind of intellectual honesty that's rare. You know the difference between knowing names and knowing things. This makes you formidable, not because you know more facts than others, but because what you do know, you truly know. You can apply it, you can extend it, you can explain it, you can build on it. Your knowledge isn't dead weight you're carrying around. It's a living tool you can use to understand new things, solve new problems, see connections others miss. The mind is capable of extraordinary things, but it needs the right method. It needs to be pushed beyond passive reception into active reconstruction. It needs to confront its own confusion honestly. It needs to build structures of understanding rather than accumulate piles of facts. This is the hidden mental trick that makes you unstoppable. Not positive thinking, not motivation, harder or longer. Simply this: never accept that you understand something until you can explain it in simple terms without reference materials. Every time you study, Time you learn every time you encounter something new. Close the books and see if you can teach it. The discomfort you feel is understanding being forged in your mind. The gaps you discover are opportunities. The effort required is what transforms information into knowledge, knowledge into understanding, and understanding into capability. If there's one thing worth taking from this, it's this: stop reading to feel informed. Start explaining to become capable. The difference between those two states is the difference between someone who's heard about things and someone who actually understands them. And in any field, at any level, difference is everything. There's a pattern hiding in plain sight that most people miss completely when they're trying to learn something new. It's not about working harder or spending more hours with your nose buried in a book. It's about understanding how the mind actually builds knowledge versus how we've been taught to think it works. The difference is extraordinary. One approach leaves you frustrated, forgetting everything within days, makes ideas stick permanently, almost effortlessly. And the strange part, most people spend their entire lives using the first method. Why learning feels like such a struggle? Here's what typically happens when someone decides to learn something. They open a textbook, start reading from page 1. Try to absorb everything in order. They highlight passages. They take notes. They reread the same material multiple times. Then, test day arrives, or when they actually need to use what they learned, they discover that most of it has evaporated from their mind like water on hot pavement. Sound familiar? This isn't a personal failing. This is what happens when you approach learning the way most educational systems have conditioned us to approach it. We've been trained to treat knowledge like filling a container, pouring information in until it's full. But the mind doesn't work that way. It never has. The mind builds connections. It creates networks. It links new information to existing understanding through active reconstruction, not passive absorption. When you simply read and reread, asking your brain to memorize without giving it the structure it needs to actually understand. And without understanding, there's nothing for the memory to anchor to. The last time you really learned something that stayed with you permanently, not memorized for a test and forgotten, truly learned. Chances are, you didn't learn it by reading the same explanation over and over. You learned it by wrestling with it, by trying to use it before you fully understood it, making mistakes and correcting them, by explaining it to someone else, even if that someone was just yourself talking out loud. This is the pattern. The mind learns by doing the work of reconstruction, not by passively receiving information. Every time you force yourself to recall something without looking at the source, every time you try to explain a concept in your own words, every time you attempt to solve a problem before checking the answer, engaging the exact mechanism that makes learning permanent. But we resist this. We resist it because it feels harder. It feels less efficient. When you're reading a textbook, you're making progress. The pages turn. The material looks familiar. You get that comfortable sensation of recognition. But recognition isn't understanding. Recognition is just your mind saying, yes, I've seen these symbols before. That's not the same as being able to reconstruct the idea from scratch. Here's the fundamental principle that changes everything. Your mind doesn't store information like a filing cabinet stores folders. It stores the ability to regenerate ideas. Think about how you remember a song. You don't store every note in some mental database. You store the pattern, and your mind regenerates the melody when you need it. Learning works the same way. When you try to recall something, when you struggle to regenerate an idea without looking at your notes, brain strengthens the pathways that allow you to reconstruct that knowledge. The struggle isn't a sign that the method isn't working. The struggle is the method working. Feeling of difficulty, that mental strain when you're trying to remember or work something out, that's your brain building the exact pathways you need. Now, most people make a critical mistake. They feel that difficulty and think they're not ready. They think they need to study more before testing themselves. So they go back to rereading, reviewing, going over the material again and again until it feels comfortable. But by doing this, avoiding the very process that creates real learning, The brain needs resistance to build strength, just like muscles need resistance to grow. You're reading material for the third time, and it all seems obvious. You're not learning. You're experiencing the illusion of competence. The material seems clear because you're looking right at it. But close the book and watch how quickly that clarity evaporates. What you want to do instead is close the book much earlier than feels comfortable. Before you think you're ready, try to write out the main ideas from memory. Not word for word, in your own understanding. If you can't do it, that's not failure. That's information. That's your mind showing you exactly where the gaps are. And those gaps are valuable. They tell you what to focus on. Then, after you've struggled with it, after you've tried and perhaps failed to reconstruct the idea, that's when you go back to the material. Your mind is ready to learn. Now you have specific questions. Now you're not just passively reading, you're actively filling in gaps that you've already identified. The difference in retention is dramatic. This applies to everything: mathematics, physics, language, history, anything. The method is always the same: engage with the material actively, not passively. Force yourself to generate answers rather than recognize them. Build the knowledge rather than try to store it. Let's take mathematics as an example. Most people approach learning mathematics by reading through example problems, following along with the solution, nodding when it makes sense, and then moving on to the next problem. Even copy the solution into their notes. Then when they sit down to do problems on their own, they're stuck. They can't replicate what seemed so clear when they were looking at the example. Why? Because watching someone else solve a problem and solving it yourself are completely different mental activities. When you're watching, you're following a path someone else has cleared. When you're solving, you're clearing the path yourself, and it's only in clearing that path that you actually learn where the obstacles are and how to navigate around them. The effective approach is this: look at a problem, close the book, try to solve it. Even if you have no idea where to start, try anyway. Write something down. Make an attempt. The attempt itself, even if wrong, prepares your mind to understand the solution in a way that passive reading never could. When you then look at the solution, just following steps, you're seeing what you missed, understanding why your approach didn't work, building genuine understanding. The same applies to reading difficult material. Don't just read a chapter from start to finish, taking notes along the way. Instead, read a section, close the book, and try to explain the main idea to yourself, out loud if possible. Use your own words. Draw your own diagrams. If you can't do it, if the explanation falls apart or doesn't make sense, that tells you exactly what you need to reread. You're not rereading everything. You're strategically going back to the specific parts that you couldn't reconstruct. This makes studying more efficient, not less. You spend less time overall because you're focusing your effort exactly where it needs to go, than spreading it equally across material you already understand and material you don't. Now, there's a deeper reason why this pattern works. It has to do with how knowledge exists in the mind. Understanding isn't a thing you possess. It's a process you can perform. When you truly understand something, what you have is the ability to reconstruct the reasoning, to regenerate the concept from fundamental principles. You don't need to remember every detail because you can derive the details from the underlying structure. This is why someone who genuinely understands a subject can explain it in multiple ways, can answer questions they've never heard before, can adapt their knowledge to new situations. Retrieving memorized answers. They're generating answers based on their understanding of how things work. And how do you develop that ability to generate rather than retrieve? Practicing generation. By forcing yourself to work things out rather than looking up answers. By explaining concepts in your own words rather than repeating the textbook's words. By solving problems rather than reading solutions. The mind is remarkably good at finding shortcuts. If you give it the option to recognize an answer rather than generate one, take that option every time. Recognition is easier, faster, requires less energy. But recognition doesn't build understanding. Generation builds understanding. This looks like in practice. Suppose you're trying to learn the physics of how objects fall. The standard approach would be to read about gravity, read the equations, study example problems, maybe do a few practice problems that are very similar to the examples. You'd feel like you understand because the equations look familiar and the examples make sense. But now try this before reading anything. Try to figure out on your own what determines how fast something falls. Just think about it. Come up with hypotheses. Does the weight matter? Does the height matter? Write down your ideas. They'll probably be wrong. That's fine. That's perfect, actually. Now, when you read the actual explanation, you're not just passively receiving information. You're comparing your ideas against what's really happening. You're seeing where your intuition was right and where it was wrong. You're building understanding by seeing the contrast between your initial model and the correct model. This creates learning that sticks because you're not just memorizing facts, understanding why those facts are what they are and not something else. This works for everything. Before reading a historical account, ask yourself what you think happened and why. Before learning a formula, try to derive it yourself from principles you already know. Before accepting an explanation, try to come up with alternative explanations and see if you can figure out why they don't work. You're not trying to reinvent everything from scratch. You're preparing your mind to understand by engaging it actively. You're creating questions that the material will answer. A mind with questions learns differently than a mind that's just trying to absorb whatever it's given. The beautiful thing about this approach is that it makes learning interesting. Actively working things out when you're testing your understanding, when you're catching your own mistakes, you're engaged. You're not bored. The mind likes problems. It likes puzzles. Give it the work of figuring things out and it performs magnificently. Ask it to sit still and absorb information passively, and it rebels. This is also why explaining concepts to others is so powerful for learning. When you explain something, you can't rely on recognition to generate the explanation from your understanding, and in doing so, you immediately discover what you actually understand versus what you only thought you understood. The gaps become obvious. The places where your explanation gets fuzzy or circular, those are exactly the places where your understanding is incomplete. You don't need another person for this to work. Explain concepts to yourself. Pretend you're teaching an invisible student. Write out explanations as if you're writing a textbook. The act of putting understanding into words, into your own words, forces a kind of mental clarity that passive reading never demands. And here's something crucial: afraid of making mistakes during this process. Mistakes aren't obstacles to learning. They're part of the mechanism of learning. When you try to solve a problem and get it wrong, when you try to explain something and realize your explanation doesn't make sense, that's not wasted time. That's your brain identifying exactly where to focus its effort. The education system has trained us to fear mistakes, to see them as failures. But in actual learning, mistakes are incredibly valuable. They show you the difference between what you thought you knew and what you actually know. They create the mental friction that leads to real understanding. So make mistakes deliberately before you know how to solve them. Attempt explanations before you've mastered the material. Test yourself before you feel ready. Every mistake is information. Every gap you discover is an opportunity to build genuine understanding rather than the illusion of knowledge. Think about how children learn to speak. Study grammar rules and vocabulary lists. They try to communicate, make mistakes, get corrected, try again. They're constantly generating language, testing what works, adjusting based on feedback. It's messy and full of errors, but it works. They develop the ability to generate language rather than just recognize it. Apply that same principle to any kind of learning. Generate first. Test yourself first. Try to work things out before looking up the answer. It feels harder because it is harder in the right way. Hard in the way that builds capability rather than just creating the temporary sensation of familiarity. The pattern is simple. Engage actively with what you're learning. Force yourself to reconstruct rather than recognize. Build understanding through the work of generation, passive absorption of information. Test yourself before you feel ready. Make mistakes and learn from them. Explain concepts in your own words. Struggle with problems before looking at solutions. This isn't a trick or a hack. This is just aligning your study methods with how the mind actually learns. The mind learns by building the capacity to regenerate knowledge, not by trying to store it like data in a file. Give your mind the work of regeneration, and it will build genuine, permanent understanding. Everything you truly know, you know, because at some point you did the work of figuring it out, of working through it, of making it your own. That's the only way knowledge becomes real, not by reading about it, not by recognizing it, by generating it yourself from your own understanding in your own mind. That's the pattern. Use it and watch what happens to everything you try to learn. When someone says they need to be more productive, what they usually mean is that they've lost control of their own attention. The real problem is never productivity. The real problem is cognitive indiscipline, the inability to decide what truly deserves mental energy. An undisciplined mind confuses movement with progress. It acts before understanding, collects endless tasks, reacts to every stimulus, and calls that work. But work without direction isn't productivity, it's noise. And the more noise there is, the less clarity you have. In neuroscience, this is known as cognitive hyperactivity, a brain processing more information than it can organize. The result is exhaustion, and ironically, a deep sense of unproductivity. Discipline, in contrast, is a form of mental engineering. It's the deliberate act of limiting what enters your mind so you can preserve your ability to think. To be disciplined is to choose focus before action, and every choice is also an exclusion. Saying yes to one thing means saying no to everything else. A disciplined brain works like a filter. It cuts out useless input, prioritizes the essential, and saves neural energy. That's not a metaphor, that's physiology. The prefrontal cortex, the part of your brain responsible for focus and decision-making, consumes enormous energy. The more irrelevant decisions you make, the faster it burns out, and the harder it becomes to make the right one. That's why disciplined people appear calm. Not because they have more time, but because their brain wastes less energy fixing mistakes born from hurry. An undisciplined mind is always reacting. A disciplined mind is always directing. And the difference between reacting and directing is what separates effort from results. Have you noticed how the brain hates silence? When there's no stimulus, it creates one. When there's no urgency, it invents it. That's how the restless mind is born. A system that craves speed when it actually needs precision. Hurry is a biological reflex, not a rational choice. It comes from the same mechanism that once saved our ancestors from danger. What was useful for escaping predators has now become mental sabotage. The modern brain lives in a constant state of alert, surrounded by notifications, sounds, and microstimuli. Every phone buzz is treated as urgent, even when it isn't. And the more stimuli, the more dopamine. More dopamine, more urgency. More urgency, less clarity. That's where discipline starts to disappear. Because discipline is the ability to hold a steady intention in the presence of distractions. But an overstimulated brain loses that ability. It acts by reflex, not by decision. Neuroscience calls this dopaminergic hyperactivation. The brain starts chasing constant rewards like a radar, addicted to novelty. It becomes used to stimulation, not focus. And focus is the first thing that dies in a restless mind. Disciplined people don't have more willpower. They have less internal noise. They create conditions for the brain to think, not just react. That's why the first step toward discipline isn't doing more. It's reducing the number of stimuli that control you. A brain that reacts all the time will never command anything. And the difference between reacting and commanding is what determines the destiny of a mind. Popular culture turned willpower into a kind of superpower. If you want it badly enough, you can do it. But neuroscience is clear. Wanting is not power, it's only intention. And intention without structure is unstable. One of the most famous experiments on this was conducted at Case Western Reserve University. Researchers divided people into two groups. One group could eat the cookies on the table. The other had to resist and eat only radishes. After that, everyone was given an impossible logic puzzle to solve. The result? The group that had resisted the cookies gave up much faster. They weren't less intelligent. They had simply depleted their self-control. Willpower is like a muscle. The more you use it, the faster it tires. That explains why disciplined people seem to have more energy. They don't waste willpower on small decisions. They design their environment and routines so that the right action happens naturally. That's the key to true discipline. It's not about resisting temptation. It's about preventing it from appearing in the first place. The brain doesn't win what it must fight every day. It wins what it no longer has to face. Willpower is a scarce resource. Discipline is the system that protects it. That's why people who try to change only with motivation always fail. Because motivation is emotion, and emotion is volatile. Discipline is design, and good design doesn't rely on constant effort. It relies on intelligent structure. If you want to turn this idea into action, the first step is to stop relying on willpower and start designing your own system. The brain doesn't respect promises, it respects patterns. That means you have to replace daily decisions with fixed structures. Don't say, "I'll try to wake up early tomorrow." Say, "I'll wake up at 6, and my phone will sleep in another room." That way you remove the negotiation before it even begins. Apply this principle to everything. If you want to eat better, don't wait to resist hunger. Organize your fridge so the right choice is the easiest one. If you want to study, define the exact time and place it will happen every day. Keep both constant. The brain learns through context. When the body recognizes a pattern, it switches to automatic mode. The secret is to reduce the number of decisions you need to make. The fewer choices your brain has to process, the more energy it has left to execute. That's what separates a disciplined person from a tired one. The disciplined don't constantly wonder what they should do. They simply follow the system they built. So stop trying to be strong. Start being strategic. Design your days the way an engineer designs a machine, with processes, not with hope. Self-control isn't the act of resisting. It's the result of having prepared the environment so that resistance isn't necessary. The human brain is a machine built for efficiency. It hates conscious effort. Anything that can be turned into a pattern, it turns into one. Anything that can be automated, it automates. That's why habits are so powerful and so dangerous. They don't ask for permission. A repeated behavior gets encoded into automatic circuits outside your conscious control. The mind starts executing it on its own, like a background program running quietly beneath awareness. Discipline is exactly that, a mental code, learned and repeated until it becomes natural. Disciplined people don't wake up every day fighting laziness. They wake up and execute, because disciplined behavior has already become part of their neural identity. Science calls this implicit learning, the type of learning that happens without you realizing it. Each repetition strengthens a neural pathway. Each pathway grows stronger with use, and the stronger the circuit, the less effort it takes to repeat it. But here's a crucial detail. The brain doesn't judge whether a habit is good or bad. It only understands that something has been repeated. A disciplined mind doesn't depend on willpower. It depends on structure, repeated and consistent. Once you understand that, you realize that discipline isn't an emotional state. It's an algorithm. Every thought, every choice, every moment of resistance costs energy. The brain makes up only 2% of your body, but it consumes up to 20% of all available energy. And the area that burns the most is the prefrontal cortex, the region responsible for decision, focus, and control. When you feel tired without having done anything physical, that's your prefrontal cortex burning out. It depletes itself every time you need to decide what to do, resist an impulse, or switch between tasks. That's why undisciplined people are always exhausted. Not because they work more, but because they waste energy on useless decisions. They overthink before acting, and then act without knowing why. They live in a loop, decide, give up, regret, and decide again. The disciplined mind, on the other hand, works with economy. It reduces the number of decisions that need to be made. Everything that can be standardized is standardized. Everything that can be removed is removed. That's why highly disciplined people often seem calm, even detached. It's not a lack of emotion, it's cognitive efficiency. They treat attention as a finite resource and protect every fragment of it. Focus isn't strength, it's energy management. You don't lose discipline because you're weak. You lose it because you waste energy on the wrong things. A brain divided among 1,000 stimuli can't sustain intention in any of them.
From a neuroscientific point of view, being disciplined means learning to reduce the cost of decisions. It means turning the essential into routine so that your prefrontal cortex only works on what truly matters. The less energy you waste deciding, the more energy you have left to build. That's the math of discipline. Fewer decisions, more consistency. Less effort, more progress.
You're not as free as you think. Most of what you call choice is just a response to the environment. The brain is a machine of adaptation. It reads what's around it and acts accordingly, long before you're even aware of it. Neuroscience calls this environmental priming, external stimuli that shape your automatic behaviors. A simple example: if your phone is on the table, you'll look at it. Not because you decided to, but because your brain has been conditioned to react to that object. Every element of your environment is a trigger. Some trigger productivity, others trigger distraction. That's why undisciplined people live in conflict. They try to change behavior while keeping the same environment. Discipline doesn't grow in chaos. The environment must support the behavior you want to repeat and make the wrong one harder to perform. It's a biological rule. The brain always follows the path of least resistance. If sweets are in the cupboard, you'll eat them. If your phone is by your bed, you'll reach for it. If the people around you live distracted, you'll imitate them. That's not weakness. It's social neuroplasticity. You become a reflection of your surroundings. The disciplined person understands this and acts like an engineer. They design the environment before depending on willpower. They remove the wrong triggers and position the right ones. They keep visible what they want to remember and out of reach what they want to forget.
If you want to build discipline, the first step is to physically clean the space where you live and work. Look around you. Everything that doesn't contribute to the kind of person you want to become has to go. Objects, noises, distractions, people, all of them are environmental code, and your brain is reading that code constantly. Every single element around you is a silent instruction. Start with the place where you work or study. Remove the excess. The brain thinks more clearly when the environment communicates order. Then look at where you sleep. Your room should signal rest, not stimulation. If your phone is your biggest enemy, keep it out of physical reach before you go to bed. The brain needs real barriers to respect real limits. At the same time, reposition the triggers that help you. If you want to read more, keep the book visible. If you want to exercise, set out your workout clothes the night before. If you want to wake up early, put your alarm clock far from the bed. That forces your body to act before your mind starts negotiating with laziness. Don't rely on willpower. Rely on design. You don't need to be stronger than your distractions. You need to be smarter than them. Create environments that push the right behavior forward and make the wrong one inconvenient. When the environment changes, behavior changes. And when behavior changes, identity begins to take a new shape. That's how discipline is built intelligently, through spatial design, not through resistance. The brain adapts to everything it repeats, including the world around it. So if you really want to change, don't start from the inside out. Start with what surrounds you, because the world around you is programming your brain every single day, with or without your permission. The brain is the best student in the universe, but it doesn't learn from words, it learns from repetition. Every time you repeat an action, the same neurons fire together, and when they fire together, they form stronger connections. That's what neuroscience calls synaptic plasticity. Discipline is simply using this principle in your favor. It's not about forcing yourself to change, but about teaching the brain until it learns to act on its own. And the kind of learning that truly reshapes behavior is implicit. It happens beneath awareness. To train your brain to learn automatically, follow a simple structure. First, pick a single, measurable behavior. Nothing vague like, I'll change my life. Choose something concrete and observable. I'll study for 30 minutes. I'll walk for 10. I'll meditate for 5. The brain learns through repetition of specific patterns, not abstract intention. Then, repeat the action at the same time and in the same place until it feels automatic. Consistency creates predictability, and predictability creates neural comfort. The more stable the context, the faster the brain binds the behavior to the environment. And finally, never break the chain. Each day of repetition is a vote for the new circuit. Each break
Reset's part of the process. That's why consistency matters more than intensity. Even on bad days, do the minimum required. The goal is simply to keep the pathway alive inside the brain. That's why fighting a bad habit is useless. You don't beat addiction by resisting it. You beat it by offering the brain a better reward. Dopamine is the messenger at the center of this process. It's released not when you receive pleasure, but when your brain anticipates it. That means a bad habit isn't fueled by the act itself, but by the expectation of relief. And this is where the scientific strategy of substitution begins. You must change the address of pleasure. Start by identifying the trigger behind the habit. It's rarely the behavior itself that controls you. It's the context that activates it. Notice what comes before: the time, the place, the emotion. Smoking, for example, might not be the addiction. The trigger is the break, the pause, the momentary relief. Then, replace the behavior but keep the trigger. The brain needs continuity, not rupture. If stress is your cue, trade the cigarette for deep breathing, a short walk, or a sport you enjoy. The stimulus stays the same, but the response changes, and over time, the new response grows stronger. Next, increase the reward of the new habit. Pair it with genuine pleasure. Listen to music, track your progress, celebrate small wins. The brain must see that the new path also produces dopamine. Without pleasure, no habit survives. And finally, remove access to the old circuit. As long as the old stimulus is nearby, the brain will return to it. The environment must support the new route. Temptation should never be within reach. With time, the new behavior starts to bring the same relief the old one did. Dopamine moves to a new address, and when that happens, the brain understands. This is the new pattern. Substitution is the most intelligent form of discipline because it works with the brain, not against it. You don't have to fight your impulses. You need to redirect them. You can have the sharpest mind in the world, but if the body is unregulated, discipline won't last. The brain is a physical organ, and its ability to make decisions depends on the chemistry that fuels it. That's why sleep and biological rhythm are as essential as focus. During deep sleep, the brain performs two critical functions. It consolidates recent learning and habits, and it restores the prefrontal cortex, the center of self-control. Sleeping poorly is like starting the day with the handbrake on. You can still move, but every decision takes twice the effort. That's why tired people are more impulsive. An exhausted brain seeks fast rewards. Discipline begins with the circadian rhythm. The brain operates in roughly 24-hour cycles, what we call the circadian rhythm. Within that rhythm, hormones like melatonin, cortisol, and dopamine rise and fall naturally, defining periods of energy, focus, and rest. Ignoring that rhythm is like trying to swim against the current. Going to bed late, waking up to alarms, and drowning yourself in coffee is the perfect recipe for a restless, unstable mind. You can master your thoughts, control your impulses, and still fail to be disciplined if you ignore the biological clock that governs everything inside you. Discipline isn't only a mental act, it's physiological. The brain, focus, and willpower all follow the rhythm of the body, and when that rhythm breaks, the mind becomes unstable and vulnerable to distraction. Sleep is the first pillar of this structure. During deep rest, the brain maintains the circuits that help you decide and resist. It clears chemical waste, reorganizes information, and reactivates the neural connections linked to memory and self-control. Sleeping too little is like trying to think with loose wires. You can still reason, but the system keeps short-circuiting. Impulsivity rises, focus fades, and willpower drains faster. The body operates in cycles called circadian rhythms, roughly 24-hour variations that regulate everything: mood, energy, concentration, and hormone release. When you sleep and wake at random hours, you force the brain to recalibrate the system every single day. That steals energy and destroys consistency. Disciplined people don't control time. They align with it. That's how they sustain stable energy, while the rest of the world swings between euphoria and exhaustion. If you want to train your brain for discipline, start with the body. Set a fixed bedtime, ideally before 11 p.m. That's when your body activates its natural restoration processes. Wake up close to sunrise. Natural light signals the brain that a new cycle has begun, balancing cortisol and dopamine. Before bed, eliminate artificial stimuli. Screams trick the brain into believing it's still daytime, blocking the release of melatonin, the hormone that prepares you for rest. Dim the lights, slow the pace, and repeat this every night. With time, your brain will recognize the pattern and fall asleep on its own, without struggle. Discipline is born from predictability, and sleep is the ultimate training in predictability. Sleeping well isn't indulgence, it's strategy. It's the moment when the brain rebuilds itself for the next day. A rested body decides better, resists more, and thinks clearly. The undisciplined try to control the mind without tending to the body. The disciplined understand that body and mind are one system, and that rest is a structural part of the order that keeps everything standing. Every human behavior is driven by a reason, but most people never bother to find theirs. They say they want to change, but they don't know what they're chasing or what they're running from. Without clarity, the brain simply doesn't obey. The human mind is wired to seek pleasure and avoid pain. Those two poles form the most primitive and most powerful motivational system that exists. And it's precisely this system that governs discipline. When the reason is weak, the brain chooses immediate pleasure. When the reason is strong, it endures discomfort. Discipline, therefore, doesn't come from strength. It comes from emotional clarity. If you don't know what's at stake, your mind will give up the moment pain appears. To uncover your true why, use a simple but profound method. Ask yourself why 5 times. Each answer pushes you one level deeper toward the truth. You might start with something superficial like, I want to wake up early. But as you keep asking, you reveal the real motive beneath it. I want to wake up early. Why? Because I want more time. Why? Because I want to work on my personal goals. Why? Because I want to change my life. Why? Because I can't stand the feeling of wasting my potential. It's at that final layer that the brain understands. It must feel the emotional consequence of what you want or what you fear losing. Motivation doesn't live on the surface. It lives in meaning. But there's an important detail. The right reason isn't purely positive. The mind also needs a negative reason, something to escape from. Pain is a powerful fuel when consciously directed. Think about what will happen if nothing changes. What will your life, your body, your mind look like 5 years from now? Visualize it vividly. The brain responds to anticipated pain with the same urgency as real danger. A strong why is always dual, something to move toward and something to move away from. That tension creates direction. When you know where you're going and what you refuse to return to, discipline stops being a struggle. It becomes self-preservation. You don't maintain a habit because you're strong. You maintain it because you've understood the cost of quitting. The brain obeys the most emotionally real reason, and when the reason is true, the behavior becomes inevitable. Human beings act according to who they believe they are, not what they say they want. The brain doesn't execute intentions, it executes identities. Every time you say, "That's just how I am," you're writing a line of code inside your mind, and the body follows that code without question. That's why true discipline begins the moment you stop seeing yourself as someone trying to change and start seeing yourself as someone who is disciplined. Your internal language is the interface of your brain. It shapes behavior long before action ever takes place. When a person says, "I'm trying to be organized," the brain hears, "I'm not there yet." But when they say, "I am an organized person," the brain interprets that as a command for coherence. The mind begins searching for behaviors that confirm that identity. Neuroscience calls this cognitive dissonance, the discomfort of acting against what we believe ourselves to be. And it's exactly that discomfort that stabilizes the new behavior. With each repetition, the brain reinforces the cycle. Action, arrow, coherence, arrow, identity, arrow, new action. Over time, behavior stops being a decision and becomes a natural expression of who you are. But there's a subtle difference between those who change and those who only talk about it. Identity isn't created by affirmations alone. It's built through concrete evidence. The brain believes what it sees you do. Every small, consistent act is a vote for the new self. It's not about doing more. It's about doing enough for the brain to recognize that the new pattern is real. Want to change your identity? Then act as if you already are the person you wish to become. Even if it feels forced at first, your brain is watching and learning. It needs consistent signals, and when it receives them, it rewrites the code. You can rewrite who you are, one action at a time. Every morning you wake up at the time you chose, the brain records, "I am someone who keeps my promises." Every time you choose focus over distraction, it writes, "I am someone who controls my impulses." These micro-evidences build a new architecture, and disciplined behavior begins to emerge automatically. A disciplined mind is, in truth, a coherent mind. It doesn't struggle to do what's right. It simply no longer knows how to do what's wrong, because the wrong no longer fits who it has become.
Discipline isn't a talent, it's a construction. And every construction begins with an act of awareness. You now understand that the brain isn't your enemy, it's your laboratory. What you repeat, it records. What you observe, it reinforces. And what you ignore, it erases. The mind is not a prison, it's a learning machine waiting for clear commands. But here's a truth few are willing to face. No one will save you from indiscipline. No mentor, book, or technique can replace the moment you finally decide to act. Transformation is solitary, because the brain only changes when you force it to, through repetition of the right behavior, even without motivation, even without desire. That's where real strength is born. You no longer need to believe that discipline is suffering. It's simply the natural consequence of a well-trained system, a well-cared-for brain, a body in rhythm, a clear purpose, and a coherent identity. That's all it takes for the right behavior to become inevitable. Discipline isn't about doing more. It's about doing what matters consistently until what matters becomes instinct. Now I want you to do something. Pause for a moment and write in the comments, "I am becoming disciplined." That simple sentence is a milestone. When you write it, your brain understands that the decision is real, and real decisions create new neural connections. It's the first command of the new identity you're programming right now. Leave your like, subscribe to the channel, and activate the notification bell. Here, we don't just talk about discipline, we build it through science, reason, and self-awareness. Each video is a lesson for those who want to think better, live better, and master themselves through logic, not emotion. Remember this, a disciplined mind isn't born from strength, it's born from clarity. You don't conquer chaos by fighting it. You conquer it by building order within yourself. Every day you choose focus over distraction, presence over impulse, purpose over instant pleasure. Your brain records, "This is who I am now." And when that pattern stabilizes, something extraordinary happens. Discipline stops being an effort and becomes your nature. Because the true power is not in controlling the world, but in controlling yourself.